Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today, it's my pleasure to welcome Ange Akono, Assistant Professor of Civil and Environmental Engineering at Northwestern University. Ange, thank you so much for joining us today. To get us started, can you just tell us a little bit about yourself and how you first got involved in nanotechnology?
Thank you very much, Lisa. I'm really happy to be here today. I am an assistant professor at Northwestern University, and I have been working in the area of fracture and nanomaterials for close to 8 years. Before that, I did my PhD at MIT, and I did my undergraduate studies in France, and I am from Cameroon. So going back to my origin, how did I get involved in science and nanotechnology? Well, as far as I can remember, I've always been passionate about math. So I think math is kind of the link that hooked me into science and nanotechnology. My favorite pastime as a kid was to solve linear equations. My parents just kind of nurtured this love for math as I grew up, and naturally I started looking into engineering. So then I went for undergraduate studies into engineering, and I went to École Polytechnique in France, which is the top engineering school in France. And there I learned about engineering mechanics, I learned about materials, and I just wanted to learn more. So I was a little bit torn because I love mechanics, I love mathematics, I kind of dabble a little bit in finance. And I just decided to just hop into civil engineering. It kind of seemed to be the third way where I wouldn't have to choose between any directions. So then when I went for my graduate studies, this is where I got introduced with nanotechnology and just understanding, what is possible when you are able to probe the behavior directly at the nanometer length scale. And this pushed me to try to understand further how can you manipulate material, especially in the area of construction materials.
Well, that explains a lot. I saw the materials and mechanical engineering connection, and I know that some of your work is looking at concrete, so the civil engineering connection just ties it all together. So thanks for that background. So I mentioned concretes. Can you talk a little bit about the research you're doing and how you study these materials?
Yeah, so what we're looking at is we are studying the behavior of concrete directly at the nanometer length scale, and we're trying to understand different structural property relationships. One recent aspect of my work was to look at nanomaterials, but all the work are more fundamental, trying to understand, how can we tailor the nanostructure just using processing or advanced design methods. And the other aspect is developing advanced method to probe the behavior at the nanoscale. And this is where I focus on fracture. And if you ask why fracture, well, fracture is very pervasive. Like if you think like walking, on the road, you could see cracking in the pavement, or even if you think at housing, cracks in the foundation, which is a horror for homeowners. What is good with fracture is also that it's really multi-scale. So you really have this macroscopic scale where you can see it, and it goes all the way to the molecular scale where you have the breaking of atoms. And what we wanted to understand is how can we probe it and quantify it at different length scale. And in my studies, I focused primarily on quantifying fracture resistance at the nanometer length scale.
I'm curious on a sample like concrete, and is it concrete or do you call it cement? I'm not sure the proper language.
That's a very great point. There's actually a difference between concrete and cement. So to make concrete, you have to make cement with stones and sand, and you're going to obtain concrete. So at the lab scale where I'm working, we focus a lot primarily on cement in this case, and trying to understand the fundamental behavior. And I like how to mention that you have really this ductile aspect versus the brittle aspect. So whenever we are always probing the fracture response, we want to understand whether it's going to be ductile or whether it's going to be brittle. Ideally, you want to have ductile fracture because then it means that you have a higher fracture resistance and you have a wealth of toughening mechanisms. But when we try to measure the intrinsic resistance to fracture propagation, we are trying to target that brittle, that kind of rate-independent, size-independent fracture resistance property.
So looking at cements and looking at this fracture resistance, what role does nanomaterials have in these properties?
That's a very good question. What we've shown recently is that nanomaterial can enhance the fracture resistance of cement. And there's really kind of different mechanism that come into play. One that is very obvious is just that nanomaterial are going to bridge nano and micro cracks. So if you think you have a fracture and the fracture wants to propagate, well, it can't, because you're going to have a piece of nanomaterial that is going to bridge it and kind of try to resorb it and close it. So it makes it much harder for the crack to propagate. Another way that nanomaterial can play is just to absorb mechanical energy to prevent the fracture from occurring in the first place. So when there's a shock occurring, for instance, nanomaterial are going to absorb the energy, and that way you don't have any cracking that is going to occur. And finally, a third way is by modifying the structure of cement itself. And what we notice is nanomaterial are really going to close major gap and just kind of create this kind of tiny pores within the cement. So this means that when you have a crack that propagates, you are actually going to increase the surface area of the crack. And if you go back again to the fracture rate in this case, it means that you need to provide more energy to create an area of crack surface in this case. And so these are different ways where nanomaterial are going to enhance the fracture properties of cementitious materials.
When I think of cement and concrete, and you talked about different materials that come together, I think also of chemistry and that there's chemical reactions that are occurring during the processing. First of all, is that true? And second of all, that leads me to my question of interdisciplinarity. So if you could first confirm whether or not you're operating on some chemical processes as well, and then what does your lab look like with respect to disciplines that make up your research group?
That's excellent. Yes. Chemistry plays a huge role when you think about cement. One important question we are always trying to address is how do we understand the cement hydration reactions? What is the influence of the processing, of the design, even of the nanomaterial on the hydration reactions? But it's not just when we talk about cement, but also when you talk about cement alternatives in this case. And this is where chemistry is even more the driving factor. We need to understand the chemistry because it is going to dictate the microstructure, it will dictate the mechanical properties. Now, going back to interdisciplinarity, my research is highly interdisciplinary, and I collaborate a lot with material scientists. So I have a significant amount of close collaboration with my material scientists. And also my background, as I shared, is mechanical engineering. So I kind of think of myself as like a mechanical engineer working with materials engineer or material scientist and trying to apply that knowledge to civil engineering.
So I have a couple of questions that we ask all of our guests. I want to first ask your thoughts and your perception on looking not just at your own research, but at nanotechnology broadly. We've had the National Nano Initiative for more than 20 years now, and nanotechnology is impacting a lot of different areas. Where do you think that nanotechnology has had an impact? And also, where do you think nanotechnology will play a significant role in the future?
When it comes to construction materials, the biggest impact has been the ability to probe the behavior directly at the nanometer length scale, being able to quantify it. And it's not just kind of measuring qualitatively used through imaging, for instance, using electron microscopy method. But in this case, when you're thinking of either instrumented indentation or other instrumented testing that focus primarily at nanometer length scale, being able to quantify that performance. Because then when that ability was integrated with artificial intelligence, then you have that notion of just like kind of a genome or a DNA. So when you think of a construction material, we can think of, we can have a bottom-up approach, where if you're tailoring the DNA directly, then you can really have this high rewards where you can control the behavior at a larger scale. So I think that this has been one of the major advances that has completely improved and accelerated the discovery of novel materials. And moving forward, I think that nanotechnology is going to play a huge role when it comes to sustainability. And when you think of sustainability from a very high level perspective, it is just how do we enable and promote and support population growth. So we know the population is growing exponentially. We know that they are going to be concentrated in cities, but we also know that we need to curb CO2 emissions, and cement is a huge part of it. To produce 1 ton of cement, so far we have to release 1 ton of CO2. And as a result, the cement industry accounts for 8% of greenhouse gas emissions. And that number is on the rise just because of the population that is rising. But it's not just CO2 emission, but it's also kind of sustainability, because a lot of the buildings right now are aging. So you want to be able to have something that is cost efficient, where you're going to have less repair, less performance, but also you're thinking about existing systems that are being strained. The quickest example that is coming to my mind is, so I'm living near Chicago, and recently we had a lot of heavy rains, and what happened is a lot of basements got flooded. Why did they got flooded? Is because existing infrastructures got just overwhelmed, and therefore they could no longer accumulate the excess of water, which again leads to a lot of inconveniences for homeowners. So how do we accommodate for this increased accelerated urbanization when you have the decay of the infrastructure itself, but you cannot just rebuild as you built the first time, because this time you have to be mindful of the CO2 footprint. So I really think that this is one area where nanotechnology is really going to make a big difference in the future.
Thank you for sharing your thoughts about the future. I think that's really inspiring. And I have one final two-part question for you. While I was doing a little bit of background reading, I realized that you share a passion for working with students, and that you and your graduate students have done outreach to high school students. And I think this is really fantastic and really important. So I want to first get your thoughts on inspiring the next generation of students. But then I want you to also speak directly to them and maybe share some advice or points that you would like students to consider as they look to their own futures.
That's a very tough question. Okay, so let me start with the first part. Why high school outreach? I just think it's really important to train the next generations. And a lot of my outreach has been focused a lot on just like underrepresented groups in undeserved communities. And I think it's important to inspire them. I've really tried to promote what I call the science identity. And that's a concept that other people have brought before me. So I really have to acknowledge their contribution. And the idea is that you really want the student to see themselves as a scientist. And I'm just going to give you a very simple example. When I was a teenager in high school, my mom told me, Angie, there is this great engineering school in France and I want you to go there. And that sounds very simple, but it just created that dream in me. I didn't even know which school it was she was talking about, where it was, but I just knew there is this amazing engineering school in France and I have to get there. So I could just work and study, and it didn't matter the hours, and I just had so much fun because there was engineering school in France and I had to get there. So I really think that this is really what we are trying to do, is to really instill that dream, is to make engineering seems accessible, looks cool and fun, especially civil engineering in this case. So when we go, we have this type of hands-on demonstration that we're going, we have kind of games that we're doing, playing with students, and we really want them to see themselves, to think about, oh, I could be doing this tomorrow, and that would be fun in this case. And hopefully this is going really to spark this thirst, this desire for engineering and for science and for nanotechnology. So that is to answer the first part. The second part, what can I tell them? Well, what I would tell them is that nanotechnology and science and engineering in the broader sense offers a lot of opportunities. And it's not just in terms of careers, it's really in terms of development. That's just amazing, realizing how becoming a scientist and an engineer made me a better person. It made me a better sister, a better friend, a better mother, a better spouse, a better community leader. So really, there's a lot of opportunities, and there's not one size that fits all. There's just a wide range of careers accessible. Nevertheless, it's very important to have the basics. So I would really encourage someone who wanted to go into science and engineering to get a lot of mathematics in the high school. That is very important: mathematics, physics, and chemistry. So I would really encourage them to spend time to make sure that they really have all their basics covered, to invest the huge amount of hours that is really important to be able to get there. And finally, I would really encourage them to look for opportunities for internships. That is one thing that I loved about in the United States. There's a lot of opportunities for high school to do internship in a lab or at the universities. And I did not necessarily have those opportunities growing up because I grew up in Cameroon. So I think that I would really encourage them to seek those opportunities out and to take advantage of them also.